Good day, everyone. Welcome back. We're continuing with Unit 6, which is called Relations, Equations, and Graphs in Math 10 combined, and today we're looking at Lesson 7. This lesson can be found on page 24 of your unit handout, and it is a continuation of yesterday's lesson. Yesterday we looked at the slope-intercept form of a linear equation, and today we're going to continue to work with it. Specifically, we're going to be looking at two important ideas. We're going to be looking at applications of linear equations, and the more important thing is we're going to be working on finding what's called a missing parameter. And because this is in the section on linear equations, it's going to be a missing parameter in a linear equation. But when you take Math 20-1 or 20-2, you will be finding missing parameters in other equations. And when you take 30-2 or 30-1, you will continue to find missing parameters in other equations. So this skill that we're learning here, the second bullet, finding a missing parameter in an equation, is an important one. So let's get started. We're just going to look at examples today. Reminder that a linear equation is y equals mx plus b. It's called a linear equation because the graph of y and x on a coordinate grid will be a straight line, and the slope of that line will be whatever m is. In other words, it will be the coefficient of x, and the y-intercept will be whatever the constant term is. So whatever that constant number is in the function or equation, that's going to be where the graph crosses the y-axis. So example 1, a student's council rents a portable dunk tank in order to raise money. What happens is a teacher sits on top of a seat right above the tank of water, and students pay for a chance to dunk the teacher, and they get balls to throw at a target. And if they hit the target, then the teacher gets dunked. The relationship between the number of balls thrown and the profit is given by that equation. So the number of balls thrown is x, and the profit is y. It doesn't matter whether they dunk the teacher or not. The reason why the more balls they throw, the more money they make, is because students are paying a certain amount in order to throw. So it might be $2 a throw. So you can really think of x as being the number of throws, if you like, or you can think of x as being the number of tickets that people buy to participate in the event. The first thing that we're asked to do is rewrite the equation in slope-intercept form. And we did this yesterday, but I'm going to go through my thinking again today. We have 3x minus 2y minus 600 is equal to 0. That's the equation. I would much rather rearrange the equation so that we're talking about positive y's. So what I'm going to do is I'm going to add 2y to both sides of this equation. I guess you'll just have to trust me that if you always arrange equations so the thing you're trying to solve for, the thing you're trying to get by itself, if you always start by trying to get that to be positive, you'll be more successful in algebra. So I add 2y to the right side, I add 2y to the left side. What does that give me? Well, on the left side now what I have is 3x minus 600. This is equal to 2y. And now to get y by itself, I'm going to divide everything by 2. I divide the 3x by 2. I divide the minus 600 by 2. And I divide the 2y by 2. And what I end up with on the right-hand side is y. And it's equal to, I'm going to write this 3x over 2 as 3 halves x. And then minus, well, 600 over 2 is 300. Now I've rearranged this equation so y is by itself, but if I choose to write y equals 3 halves x minus 300, these two things are the same. It doesn't matter whether I write y now on the left or the right. If y is equal to 3 halves x minus 300, 3 halves x minus 300 is equal to y. It doesn't matter how we look at it. So we have written the equation in slope-intercept form. And I'll rewrite it on the next page here. The equation is y is equal to 3/2 x minus 300. In order to make sense of this, I'm going to take 3 divided by 2 and write this as y equals 1.5 times x minus 300. And we're asked for the slope of the line. Well, the slope of the line is the number in front of x. So the slope of the line is equal to 1.5. What does it represent? Well, in order for you to decide what the slope represents, you need to consider the graph. I'm not saying we need to construct a detailed graph here. I'm just saying you need to consider what the graph is of. The graph is of x, which is the number of throws, and y, which is profit. It's money taken in. And that means when you have a slope of 1.5, this profit will be in dollars. And in terms of a rise over a run, this will be $1.5 per throw. Somebody, we just did it by looking at an equation, but somebody could make a graph of this, and we'll get back to the graph later, and take 2 points and determine a rise and a run, but they're going to be dividing an amount of money by a number of throws. And that's why the slope has dollars per throw as units, is what we would say. So what does the slope represent? It represents the idea that every time a student throws a ball, they have to pay $1.50. So if I walk up, and maybe other teachers can buy throws as well, and I say I want 2 throws, they're going to charge me $3 because it's $1.50 per throw. What is the y-intercept? Well, again, I'll write the equation. The equation is y equals 1.5x minus 300. And I'm going to go back to my graph here. The y-intercept, by the way, is negative 300. And don't forget, the y-intercept is where x equals 0. Actually, in retrospect, I'm going to try to explain what the y-intercept represents without looking at the graph. This is 0 throws. A y-intercept is always where x equals 0. And this is negative $300 is the profit. What does that mean? It means if they set up the dunk tank, they make arrangements for a company to fill up the dunk tank and drop it off on the school grounds, and for some silly, strange reason, they sell 0 tickets. You can use your imagination to come up with a reason why that's the case. Maybe school was canceled because there was a flood in the building, so the event didn't take place. Whatever your imagination can conjure up, you can come up with some reason why there were no throws. If there were no throws and the y value is negative 300, I'm going to go back to the graph now, that means that this line crosses the y-axis at negative 300. This is negative $300. So what it represents is how much money they would lose if they did not sell any tickets or any throws. In other words, negative 300 is a loss of $300 if no throws are sold. Really, when you think about it, the reason for that is the dunk tank probably cost $300 to rent. And that's why the graph showing the number of throws and profit doesn't look like this. It doesn't start with no throws and no profit. and they earn money right away. The reason why it looks like this is they have to earn $300 before they can start making a true profit. D, the break-even point is a point at which money raised equals money spent. In other words, really the break-even point is where the profit is equal to nothing. The profit is not positive. I mean, the Students' Union wants a positive profit. When I go to the graph, in this region here, they are happy. They are happy here. They are happier here. They are happier here. And they are happier here because their profit is going up. They're pretty sad right here, and they're even sadder down here. In the region of the graph below the x-axis, they are losing money because the profit is negative. In the region above the x-axis, they're gaining profit, or they're making profit because the profit is positive. The break-even point is where the profit is zero. So on this graph, everybody, I want to get rid of my smiley faces here. On this graph, this is the break-even point, where they're making zero profit. They're not earning money and they're not losing money. And that's the x-intercept. So to find the break-even point, we just have to find the x-intercept. Because the profit equals zero. We went over that yesterday. A y-intercept is where x equals 0, and x-intercept is where y equals 0. So we're going to take our equation, y equals 1.5x minus 300. We're going to change y to 0 and have 0 equals 1.5x minus 300. Very basic two-step junior high-ish equation to solve. Step 1, add 300 to both sides, giving us 300 equals 1.5x. Step 2, divide both sides by 1.5 to get an answer. X, of course, is a number of throws. X, of course, is a number of throws. So we need to take 300 divided by 1.5. Voila, 200 throws. So if they sell 200 throws, they're neither happy nor sad. They didn't lose money, but they didn't earn money. If they sell, well, I'll put it this way. If X is bigger than 200, they are happy because they are earning money. If X is less than 200, they are unhappy because they are losing money. All right, let's take a look at example 2. A very similar example, except I'm not telling you exactly what to do for the steps. Parents of the members of a cheerleading squad rent a hall, and they put on a talent show. So they, one of the cheerleaders does a magic show, one does a dance routine. They put on a one-act play, and they sell tickets to the community, and it says the profit Y in dollars can be represented by that equation where X is how many tickets sold. What is the slope of the line? What is the y-intercept of the line? And what do they represent? Well, I'm not telling you that you need to rearrange it for Y. In example 1, the very first thing I said was rewrite the equation in slope-intercept form. And the reason you do that is so you can look at the slope and the y-intercept to answer questions. Well, here I'm not telling you to do that, but if you want the slope and the y-intercept, then you need to rearrange this for y. Very simple rearrangement. I am going to add y to both sides to get positive y is equal to 12x minus 840. So what is the slope? The slope is the number in front of x, which is 12. And since this is all about calculating profit for y, and x is how many tickets you sell, the slope is $12 per ticket. So that's the meaning of it. It means that every ticket they sell, they get $12. What's the y-intercept? The y-intercept is the number by itself, which is negative 840. So what is y? Y is a profit. This is the profit, and I'm going to put the word profit in quotation marks, if no tickets are sold. I cannot come up with a scenario under which they organize this event and they fail to sell any tickets. I guess maybe the event is canceled and they have to refund all of the tickets. I'm not sure. But getting back to the question, what that negative 840 means, since it's a negative number, it's not really profit. It's probably that $840 is the cost to rent the hall. It's the amount of money they're putting up front in order to create the event, and they have to sell enough tickets to overcome that. And again, just, roughly a graph of this, since the y-intercept is negative 840, the graph is going to start here. The slope is 12, which is a positive number. They are making money here. They are losing money here, and this point would be the break-even point. The reason why they're making money up top is this y is money, and this is 0. It's actually profit. So if you're in a positive region, you have a positive profit. If you were in a negative region, you have a negative profit. How many tickets must the parents sell to reach the break-even point? Well, the break-even point is right here. This is the break-even point. And that's where y is equal to 0. Because we can see it's equal to 0 there, or because it's really an x-intercept. So we want to find the x-intercept, which is where y equals 0. We have y equals 12x minus 840. So 0 equals 12x minus 840. I'm not going to write this down, but you would have to add 840 to both sides to get rid of the 840 on the right, and you would get 840 equals 12x. And then you would have to divide both sides by 12, so you would get 840 over 12. So 70 tickets. If you were to graph this using technology, you would discover that this would have a value of 70 for x. So as soon as you go above 70, your profit is positive. If you go below 70, you're losing money. At 70, you break even. Break even means you didn't earn anything and you didn't lose anything. It's not a great situation, but it's not a bad situation. Number 3, Asha has selected a hotel for her wedding reception. The cost involves a fee for the ballroom and a buffet charge that depends on how many guests there are. So we've got the independent variable, which is x, is the number of guests, and the dependent variable, which is y. And I just remembered I've got this on another page because I want to show you something. Here's the data table. This again is x, and this is y. X is the number of guests. Y is the cost. Y is always the dependent variable. The cost depends on the guests. So what I want to do is compare what's happening when we go from here to here and here to here, because both of these are an increase of 25 people. What about from here to here for cost and here to here for cost? Well, I can take 1,800 minus 425. 1,800 minus 425 gives me 1,375. If I take 3,175 minus 1,800, it's 1,375. So these are both going up by 1,375. And what that is telling you is that the slope is 1,375 divided by 25. It's telling you that on a graph, if we take a particular point here and we increase 25 people, it's going to go up 1,375. And we'll calculate that slope in a second. Now, what about from here to here? Well, from here to here, it goes up 50. And from here to here, let's see. It's 59.25 minus 31.75, which is 27.50. So this goes up by 27.50. That means from this number of guests to this number of guests, using V's for y, we can calculate a slope. A slope is, well, from 31.75 to 59.25 is 27.50. Over, this time we increased by 50. So let's calculate the slope between the third point and the fourth point, or actually I guess it's, yeah, the third point and the fourth point. It's 27.50 divided by 50. If I can get this to erase, there we go. 27.50 divided by 50 is 55. If I look at the slope for going from the first to the second point or the second to the third point, it's on the right of my calculator. It's 1375 divided by 25. It is, let me do that again, 1375 divided by 25. It is still going up at a rate of 55. And by the way, this is going to be dollars per person. I've gone through all of that to explain to you that this is linear. Now that we know it's linear, determine the equation. Well, if it's linear, the cost will be equal to the slope times the number of people plus the y-intercept. This is how we find the equation of a linear function. Well, we've already determined the slope. The slope is 55, the slope is $55 per person. Whether you calculate it here or whether you calculate it here, you're getting a slope of 55. So y is equal to 55, x plus the y-intercept. Well, the y-intercept is given to us right here. The y-intercept is the value of y when x is 0, and that's 425. And if I asked you to interpret this equation, the 55 for a slope is $55 per person. That's for the buffet. And the plus 425 is $425, probably for the hall rental. Is it a hall? Ballroom rental. And what this graph would look like, it has a positive y-intercept and a positive slope. It would look like that. Let's take a look at number 4. The equation W equals mt plus 10 models how the temperature of water, W. So I think it's useful to just sketch a graph and put W here. Well, we won't even sketch it yet, but draw the axes, and T here. So W is the temperature of the water in degrees Celsius, and T is the time the water is on the burner or the stove in minutes. And I just want to write the equation down here where I can write it a little bigger and refer to it. This is the slope. This is y. This is x. That means this is the y-intercept. So the graph is going to start here at 10, and there's a certain slope. Now, how do we find the slope? We call this letter, I haven't really called it this yet, but this letter is not a variable. W and T are variables. I want to actually make a note of that. I think this is a very important idea in high school math. W and T are variables. In the equation y equals mx plus b, these two things are parameters. We call them parameters. So we are asked to find the value of the missing parameter. And the key is, I'll write the equation down now here where we're going to show our work, W equals m times t plus 10. The key here is we know an ordered pair. We know that after 5 minutes, the temperature of the water is 19. So I can put 5 in for t into that equation and 19 in for w, and I will be able to find that missing parameter. 19 equals m times 5 plus 10, and we solve that equation. I can rewrite it as 19 equals 5m plus 10. If I subtract 10 from both sides, I get 9 equals 5m. I will just show that. What I did was I subtracted 10 and I subtracted 10. That means that when I divide both sides by 5, I get m is equal to 9 over 5, or what is that, 2.2, and that would be degrees Celsius per minute. But the bottom line is now we know what m is. So our equation is W equals 2.2, which is the slope, times t plus 10. How long is it going to take for the water to boil? So finding that missing parameter gives us now an equation that opens up the door to answer any question about what's going on here. By the way, the time it's going to take for the water to boil is the time it's going to take for it to reach 100 degrees Celsius, because that's where water boils. So we're going to change this equation and we're going to put 100 in for W and solve for T. Very basic equation to solve. Subtract 10 from both sides and get 90 equals 2.2t. And now we can take 90 divided by 2.2. It's getting late in the day for me, so I'm going to have to rely on my calculator here. Oh, I never would have got that in my head. About 41 minutes. T equals approximately 41 minutes. I mean, you may look at this and go, that doesn't seem reasonable, but it doesn't really give you a context about what's going on here. I mean, the stove is obviously at a very low temperature. It's increasing by 2.2 degrees Celsius per minute. So to go from 19 degrees, or from 10 degrees Celsius, which is what the initial temperature is, up to 100, it's going to take quite a few minutes. So the answer to the question for B is 41 minutes. Not a very great question. I would change it next time so that the slope is higher and it would heat up a lot quicker. All right, a decorator's fee can be modeled by this equation. The fee equals 75t plus B. I cannot stress this enough. This, in your head, needs to be thought of as something. And what it is a missing parameter. If we knew the value of that letter, then we could solve problems with this. By the way, once again, these two things are variables. These two things that I'm highlighting in blue are variables. The parameters are the things I'm highlighting in yellow. The slope and the y-intercept are the parameters of the equation. They tell you what the equation looks like. Now, we already know what the slope is. It's 75, but we don't know the parameter b. So b is a missing parameter. How do you find a missing parameter? You always load into the equation an ordered pair. So we have time and fee, and it says if the decorator spends 4 hours, they charge $450. So this ordered pair gets loaded into the equation. Wherever we see a T, we put 4. Wherever we see F, we put 450. So I have 450 equals 75 times 4 plus B. You're just getting started with high school algebra, but to solve an equation, it's always a good idea to simplify things first. Nobody walks around saying 75 times 4. You figure out what 75 times 4 is, and it's 300. Now I have 450 equals 300 plus B. If I subtract 300 from both sides, I get B equals 150. So think about this in terms of what a graph would look like. The y-intercept is $150, and that's for a fee. The slope is $75. This is in hours. So the slope is $75 per hour. So what does the y-intercept represent? It represents the decorator's flat fee. It doesn't matter whether they're called out to your house and you spend 1 minute there or 10 hours there, everybody's going to pay that $150. And then on top of it, you're going to pay $75 per hour that the decorator is there. How many hours does the decorator work if the client is charged $9.75? Well, now we have the formula. The fee equals 75T plus, I think it was 150. I'm going to have to go back and just double check. Yeah. So what this question has us doing is finding the time for a fee of $9.75. So we're going to put $9.75 here. And I hope you're realizing that what's going on behind the scenes here is we're learning about, well, linear equations, but I'm teaching you how to solve equations behind the scenes. That's maybe more important than the fact that these are linear. How do you solve this equation? It's a two-step equation that, I mean, you just need to be lightning quick at solving these, especially by the time you move on to the next level. You subtract 150 from both sides. What do we get? 975 minus 150 is 825, I think, pretty sure, equals 75T. Now I divide both sides by 75. And I end up with T is equal to, I want to say 11, but I don't really trust myself right now in my head. 875 divided by 7, or 825 divided by 75. Yep, it's 11. So it's 11 hours. We have a couple more quick questions, and they're all kind of centered around the same thing we've been doing. I tell you that we have a linear function and the equation is y equals negative 2x plus b. And the question is, what is the value of b? Well, b is a missing parameter, and the only way you're going to find b is if you have numbers to put in for the variables. And you can't just randomly put numbers in. You have to put numbers in that go together. And the ordered pair 6, negative 5 is a pair of numbers that are locked together. That is saying when x is 6, y has to be negative 5. So we simplify this, we get negative 5 equals negative 12 plus b. I want to get b by itself, so that's going to be accomplished by adding 12 to both sides and getting b is equal to 7, negative 5 plus 12. So b is equal to 7, which means the equation is y equals negative 2x plus 7. Just to convince you that this works, if I grab my graphing calculator, and I go to y equals, and I put negative 2x plus 7, and I choose zoom standard, which is zoom 6. There's the graph. This graph is supposed to pass through the point 6, negative 5. If I choose trace and enter 6, and then enter, you can see it passes through 6, negative 5. It worked. And the final example, a linear function is y equals kx minus 8. Find k. Well, k is a missing parameter. K is really the slope, but you're going to find from time to time in high school math, people try to trick you, and they, instead of putting, say, m for slope, they use a letter like k. But you know that these two things are variables. Everything else in the equation is a parameter, which means it's a number that's the same all the time, whereas the variables change. So this k is a missing parameter. How do we find the missing parameter? We load in to the equation an ordered pair, which in this case is negative 3, 10. So I put 10 in for y. I put negative 3 in for x. I simplify it just ever so slightly. I write k times negative 3 as negative 3k minus 8. And I'm solving for k. You don't have to move the k's to the side where they're positive. Let's leave the k's alone this time. We have to get k by itself, so the first step is to add 8 to both sides. That gives me 18. That's an 8, is equal to negative 3k. The reason why I don't like you to use negatives in front of variables is very often people forget about them. I need to divide both sides of this equation by negative 3 to cancel the negative 3's. And I get k is equal to 18 over negative 3, which is negative 6. So k is equal to negative 6. That's the answer to the question, which means our equation, I want to just make sure I've got that right. Our equation is actually y equals negative 6x minus 8. And again, we can verify that this works. I may choose to show you another thing here with the calculator. I'm going to graph negative 6x minus 8, and I'm going to go graph. If I were to go trace negative 3, it happens to fit, it does. But if I were to go trace negative 4, I don't know, does it still work? I guess it still works. I don't need to show you another method to do it. Bottom line is this graph, y equals negative 6x minus 8, does in fact pass through that point that it was supposed to pass through, negative 3 comma 10. So just to show you that again, there's that point, negative 3 comma 10, and it's on there. That's it. That's all for the lesson. You know how to get a hold of me. If you need to, send me an email, and I really hope to see you in school soon. Take care.